Question 9. Oh, I love this question. It just looks terrifying, but actually it's not too scary. So this is the moments question. You've got basically a track where you've got 3 downwards masses. Okay, each of these are mg. I'm not going to read the whole question out. But they aren't fixed distances. So each of these distances can alter. Okay, and it gives you, in these 3 inequalities, the distances that it could sort of like vary between, right? And then you've got 2 wires, so you've got tension 1 and tension 2. Okay, so it's basically a moments question that's been dressed up to look terrifying. Okay, the track itself doesn't have any weight. It says it's light. We know the total length of it is 1.8. We've got various fixed distances and we've got altering distances. Okay, so given that T1 and T2 represent the tensions in wires 1 and 2 respectively, show that T1 is this expression and find a similar expression for T2. Okay, so we're going to use moments. If we want an equation that has T1 in it but not T2, then we want to take our pivot point at T2. Okay? So if we take our moments equation, okay, I'm going to sort of half refer to this little simple diagram and half look at this one as well, right? Let's just fill in, if that's 0.4 and that's 0.4, that adds up to 0.8. And if the total length is 1.8, then that's 1 metre there. Okay, and then I think we've got all the distances we need, really. So, if I'm pivoting here, think about if you spin your paper round, okay, what arrows are going the same way. Now, that T1 and that third mg are both moving clockwise, and if I spin it the other way, these 2 mg's are helping each other to go anti-clockwise. Okay, so let's think about that. So the forces that are going to help each other are this T1 and this mg. So let's write down those 2. So it will be T1 times a distance of 1 plus this mg here times a distance of dc. Okay, they're helping each other. Their moments will equal these 2 moments. So this one over here has a total distance from this point here of 1 plus dA. And the middle one, we want this distance, which is 1 minus dB. Okay, let's just times this out now. So we've got T1 plus mg dc is equal to an mg times a 1 plus an mg times a dA plus an mg times a 1 plus an mg times a negative, so I'll pull that as a minus sign, dB. Okay, so we want T1 on its own, so we'll just hop that term across. We can join these 2 mg's here, so we end up with T1 is 2 lots of mg, which is that one and that one. Then we've got a plus mg dA, we've got a minus mg dB, and as that one hops across, we've got a minus mg dc. And all we then do is take the mg as a common factor. So we've got a 2 plus a dA minus dB minus dc. Okay, that wasn't that hard. It looked terrifying, but it wasn't too bad. Okay, but that's not the 6 marks. We've got to do the same thing for T2. Now you can either take the moments from the other point, or you can do the sum of up equals down. Both will work out okay. Okay, if you did resolving vertically, and you said that T1 plus T2 is 3mg, it works out pretty quickly. You can say T2 therefore is 3mg, take away this whole expression, so you get 3mg, take away 2mg, take away dA mg, minus minus makes a plus, dB mg, and a plus dC mg, which gives you a single mg there, minus dA, plus dB, plus dC. That's your similar expression. Okay, if you didn't want to do that, you could take a pivot point at T1, okay, and take your moments and do the process for moments again. Okay, so if you were pivoting at T1, do a spin again of your page, and you will realise that this time it's this one and this one that are helping each other, and these two are opposing, they're turning it the other way. So you would have T2 times 1 plus mg times dA being balanced by mg times this distance, which is dB, plus mg times 1 at dC. And if you went through that process, you would get back to that expression again. Okay?